Okay, let's start. We'll take a look at binomial distribution assignment, right? Not very well done. Part 1 is fine. The batch is accepted as a result of inspection of the first sample. So I don't think it's a problem if we just let x be the number. Let x be the number of defective items out of 20. So x should belong to a binomial with n equals to 20, p equals 0.02. So part 1 is easy, you will get your answer. Probability x smaller or equals to 1 is 0.940. The difficult part is part 2, which actually out of the 4 parts, the most difficult is part 2. If you can identify, you can solve part 2, part 3 and part 4 shouldn't be a problem. So let us go through part 2 in particular. Alright, let's go to part 2 in particular. Let's see probability that the first sample has a defective item given. Now there's a conditional probability which most of you can identify, but many of you cannot break this down. The batch is accepted. Now, if you take a look closely at the question, there is a further sample of 10 items. So, if we take a look like that, actually you take a first sample, which is 20. Now, if you have less than or equals to 1 defective, then it's accepted. Now, if you have 1, if you have exactly 2, if you have more than 2, if you have more than 2, then it's rejected. Now, shall we take a look at the special case where it is actually exactly 2? Exactly 2 defects. Then what do? You take a second sample where n is equals to 10. Look, you take a second sample where 10 items here. Look here. So, then you see, as long as there is any defect, so now you have 0 defects. If I let this be y equals to 0, then it's accepted. And now y is equals to greater or equals to 1, then it's rejected. Hello? Sure. Right? So, now if we let y be the number of defective items out of 10, now it's 10 because we are focusing on the second sample. Now, so therefore, actually, what do you want? You want probability that x equals to 1 given that the batch is accepted. Now, how can the batch be accepted? There are 2 possibilities. Note, there are 2 possibilities. X must be smaller equals to 1, or it must be exactly 2. Then you take the second sample, and second sample you must have y equals to 0. Now, this is the most important thing. Alright, so now let's try and calculate this probability. Alright, before that we can always define what is y. If y is a number, y is also a binomial. This time n is 10 and p is still 0.02. So this probability is A intersect B. Now if x equals to 1, surely it's accepted. So this intersect this, you will still get back x equals to 1. So probability divide by batch accepted. How can a batch be accepted? Either x is smaller or equals to 1, or x is equals to 2. After that, what do? Your second sample must have 0 defective items. So times probability y equals to 0. Now if you can write that down, then you will get the answer because your x and y are properly defined. Now, can I also elaborate a bit more on this multiplication? It is a multiplication because the two samples taken are independent. So you take one after another, so you take multiply. Then you will get your answer. No big deal. 0.277. Alright? That is all I want to go through because part 3, I will just give you the answer. Right? Most of you can get this answer, 0.0432, and part 4, you get 0.0167. Now these two, I don't think is a problem if you can solve part 2. Alright? That's all. Thanks.